Let's do example 12.7. And I might be a little repetitive here, but this stuff is, I think, easier than how it comes across. So I kind of just like to derive everything myself every time I do one of these problems. So if I can find dy dx, or how fast my y changes with respect to my x changing, and that is the value of my derivative, then I can think of throwing that dx onto the other side and solving for dy as my derivative value multiplied by my dx. And my actual change in y value is approximated with that derivative value in my y, my change in y over my change in x, which is my function value times my dx, or a change in x. So if this is how I get my change in y, then my y minus y naught is f prime of x times x minus x naught. And I can just throw that y naught onto the other side and find that y is equal to f prime at x naught times x minus x naught plus the y naught. And this should be familiar to you. This is the tangent line. There's your initial y value. There's your m. Here's your change in x's. Okay, so now that I've reminded myself of what we're talking about, let's try to answer a question. Let's find dy if my function is given to me by x to the fifth plus 24x, and I want to find the differential if x is equal to 1 and dx is equal to 0.2. All right, so the differential is the dy. So my dy is given to me, where do I have that? I've got it right here. Dy is the derivative value at a point times dx. All right, my derivative is 5x to the fourth plus 24. Now I want to find my differential if my point of interest is 1 and my travel in the x direction is 0.2. So if I look over here, I'm going to be interested in the point x is equal to 1. So my x naught is equal to 1 here. And my travel in the x is 0.2. So this term could be thought of as 1.2 minus 1, right? The initial value x naught was 1, and I traveled 0.2, so this x value is 1.2. But either way, this x minus x naught term, or this dx term, is 0.2. So dy when x is equal to 1 and our travel in the x direction is 0.2. Oops, that's dy. There we go. This is going to be our derivative value at 1. So that'll be 5 plus 24. And our dx is 0.2. 5 plus 24 gives us a 29. Times a 0.2, that's 29 times a 1 over 5, or 29 over 5. So our change in y value, our differential, is 29 over 5 as we travel along our tangent line.